I apologize for speaking in English. I'm afraid my Spanish is not nearly as good as my English or several other languages, but maybe next time. Given the generally unfavorable conditions for organic materials preservation in the northern Mediterranean regions, it may come as a surprise that ancient textiles do survive in Spain, if infrequently. This happens thanks to special preservation conditions, for example, very dry conditions in caves, contact with metal, causing the mineralization of textiles, or carbonization in fire, as well as waterlogging. More importantly, tools used for making textiles, such as spindle whorls and loom weights, are ubiquitous in pre-Roman sites. Together with other evidence, such as iconography, written evidence, sheep bones, and paleobotanic record, they allow us to construct various aspects of the chaîne opératoire of textile production in prehistoric Spain, its economy, and social impact. Today's interdisciplinary workshop gathers researchers in these fields in order to bring together and to discuss the various methods and approaches to archaeological textile studies in Spain. The overall aim of this session is to demonstrate the potential of archaeological textiles and related sources for the investigation of ancient Spanish economy, technology, and agriculture, and to discuss new methods that can be applied to the investigation of ancient textiles. Carmen Alfaro's fundamental 1984 volume Tejido, Cestería and la Península Ibérica, and her continuing work in the field of textile research has paved the path for modern archaeological textile studies in Spain, and we are honored that she has agreed to be with us today to give the keynote lecture summarizing a lifetime of experience and knowledge and giving an overview of archaeological textile studies in Spain. The fact that we were able to put together such a dense and diverse program gives us hope that the field is truly coming into its own, on the par with much more developed textile studies in Northern and Central Europe. This workshop is the third in a series organized by the PROCON project, Workshop 1 having taken place in Rome in 2015 and Workshop 2 in Athens in 2016. The PROCON project, which is funded by the European Research Council Starting Grant and hosted by the University of Cambridge, is investigating the role of textile production and consumption in the formation of North Mediterranean urban centers during the Iron Age. The overarching question to be answered is, to what extent did textile production and consumption define the development of productive and commercial activities in early urban Mediterranean societies in the Iron Age? The aim of the project PROCON is to test the hypothesis that textile production and consumption were significant driving forces of the economy and of the creation and perception of wealth in a Mediterranean Europe during the period of urbanization and early urbanism from about 1000 to 500 BCE, although we cover earlier and later periods as well. The focus is on the significance of the production and consumption of textiles for the development of city-states as clothing, elite regalia, trade and exchange items, and the implications of this for other aspects of economy, such as the use of land, labor resources, and the development of urban lifestyle. The study area encompasses the territory of modern Italy, Greece, and Spain, and covers the time period from 1000 to 500 BC. The project is concerned with the following questions. How did textile production and consumption was organized? Where did the various resources come from? What were the technologies used? What was the level of organization? Who was involved in textile production and consumption? And what was the quality and quantity of textiles produced and how they changed over time in response to urban consumer demands? In exploring these questions, the project follows not only a functional approach, but also considers the value ascribed to these goods and the customs that came with them. Consumption of textiles is defined by the quantity and quality of consumables produced, which in turn depends on the level of production organization and the availability of material and human resources. The project structure hence encompasses 4 research strands within the operational chain of textile economy: resources, production, product, and consumption and exchange. The materials studied include surviving textiles, tools in textile production, archaeobotanical and archaeozoological remains, and as well as iconographic and written sources. The questions outlined above lead to the following objectives for the PROCON project. To evaluate the availability and degree of exploitation of various resources for textile production, and this we do through investigating textile fibers and dyes, archaeobotanical assemblages and paleoenvironmental data, sheep bone assemblages, landscape and transhumance patterns, wild resources, and areas of resource production and acquisition. The second objective is to assess the technological and organizational parameters of textile production. Here we look at producers, who was involved, at the techniques used, at the type and scale of production, and organization of production, this primarily through investigation of textile tools. Third objective is to explore the consumption of textiles as clothing and utilitarian goods, and to trace the increased demand for clothing through changes in fashion and in wealth accumulation, and demand for sailcloth with increased mobility. So we're looking at function and quality in textiles, we're looking at function and fashion in iconography, and looking at utilitarian textiles such as sails, which is a particularly evasive area, and we try to make time estimates of how much time it takes to produce certain types of textiles. Fourth objective is to identify the modes, means, and directions through time and space of the resource, technology, and textile consumption and exchange. Again, through quantity estimates, looking at provenance of textiles, at trade routes, and exchange of technologies. And on the basis of all of these, to provide a new reading of economic history for the period and area under consideration, which sees textile production and consumption as a major economic factor during urbanization in early Iron Age Mediterranean Europe. Throughout, we aim to have a truly interdisciplinary approach, combining a wide variety of methods, whilst developing some new approaches as well. Today's program is a reflection of that, combining papers on textiles, textile tools, paleoenvironmental approaches, including archaeobotanical and archaeological remains, iconography, and written sources. But before we begin with all these exciting papers, a quick introduction on the different stages of textile production and how various sources and methods can enlighten our understanding of textiles and their economic, social, and historical role in ancient Iberian Peninsula. Textiles represent one of the earliest human technologies, so it is hardly surprising that textile production and consumption define the development of productive and commercial activities of ancient societies, at least since the Neolithic. The generic term textile, however, covers a wide range of finished products made from a variety of raw materials. Plants such as flax and animals such as sheep were among the most important resources for making textiles in ancient Spain. The technologies of their transformation into usable fiber were complex and significantly influenced the economy of textile production throughout history, and particularly during the periods of urbanization when increase and concentration of human populations required large quantities of cloth. The first stages of textile production are thus the procurement and preparation of the raw material. In order to understand these stages, it is necessary to be able to identify the raw material used for the production of textiles. The method of choice in textile fiber identification has traditionally been transmitted light microscopy, which allows determination of gross morphology of textile fibers in both longitudinal and cross sections. Optical microscopy is, however, not always conclusive on its own. Fibers in poor condition, very dark fibers, soiled or covered with consolidant, may be very difficult to identify, while mineralized samples are impossible to analyze with this method. In recent years, scanning electron microscopy has been increasingly used for textile fiber identification, as it allows a wide magnification range up to 10,000 times and produces a grayscale 3D image of the sample's surface topography. 90% of textiles studied by our project, for example, are in mineralized forms, as you see on the slide on the left. And in 75 to 80% of the cases, we've been able to identify fiber using scanning electron microscopy. Once the textile fiber has been identified, the next step is to analyze its preparation and quality. In terms of plant fibers, it is possible to determine how well the raw material was retted and whether the yarn was produced by splicing or draft spinning, and I shall come back to these techniques shortly. For sheep wool, it is possible to assess both the original composition of original fleece and its subsequent preparation through combing or other methods. Assessment of fiber quality is based on a technique used in modern textile industry and consists of diameter measurements of 100 fibers per thread or staple and statistical analyses resulting in a distribution histogram. Once the fiber mass has been obtained and prepared, it can be converted into yarn. Different methods were used in the past to create yarn, and they can be generally divided into two categories: splicing methods and draft spinning. The technologies are mechanically and conceptually different, requiring different tools and different organization of production. The more familiar spinning process utilizes twisting and drawing out or drafting of the fibers. During spinning, yarn acquires tensile strength, which is prerequisite for weaving a textile. In order to achieve control over the fineness and evenness of the thread, the fibers must be drawn and twisted simultaneously and with the same speed. The suspended or drop spindle accommodates these requirements very efficiently. Such a spindle consists of a rod or a spindle shaft and weight known as a spindle whorl, fusaiola, a symmetrical, centrally pierced object which functions as a flywheel. Since most spindle shafts in antiquity were made of wood, often the only evidence for their use consists of the less perishable spindle whorls, which have been made from fired clay, stone, bone, glass, and other materials. Raw fiber during spinning has to be organized in some way, and the solution is a distaff, which may be handheld or fixed, although these are much more rare in archaeological record. The fibers can be twisted in two directions, producing different structural effects. For convenience, yarn is described as Z-twisted if it is spun clockwise, and S-twisted if spun counterclockwise. The vast majority of the wool yarns from Mediterranean Iron Age textiles are Z-twisted, but threads twisted in opposite directions could be combined to produce interesting structural effects known as spin or shadow pattern, something we particularly see in Italy. Two or more threads may be plied together to produce thicker or stronger yarn. Until recently, it has been regarded that all prehistoric textiles in Spain were made with 2S plied yarn. But latest research suggests that in fact they may have been spliced. Draft spinning likely developed with the use of wool, so many millennia after fiber technology developed. Before then, splicing was a technique used to convert plant fiber into yarn. It has been assumed to be a technique used exclusively in ancient Egypt and the Far East, but recent investigations in European pre- and protohistoric textiles indicate that some of this method was ubiquitous throughout Europe and the Near East, and in fact coexisted with draft spinning of wool well into the first millennium BCE. In contrast to draft spinning, during which the combed and prepared fibers are fixed on a distaff and are continuously drawn to receive a twist imparted during the rotation of a spindle, in splicing, preformed fiber bundles taken directly from plant were spliced so that the ends of the fibers would overlap. To achieve this, the plant fibers were not thoroughly retted in water or dew, or were even used green directly from the plant, and this can be observed in archaeological samples microscopically, in the presence of epidermis or more frequently in the fiber bundles, which indicate that fibers were not processed thoroughly enough to separate them from each other. We see this in most Bronze Age textiles in Europe and many Iron Age textiles in Italy and Greece, and even in recently found finds at Must Farm in the UK, a Bronze Age site dating to about 1000 BC, which I'm happy to see also. I think later we will see the finds from Terlinques that the colleagues have sent me pictures of when the news of this find have come out. The technique of yarn making, as well as the quality of the raw material, would have had a profound effect on the quality of the resulting yarn and textile. Thus, very early wool was very fine, but also short, resulting in soft but thick yarn that would have had to be fulled to make the textile stable. During the early Iron Age, fleeces with longer fibers developed, allowing the spinning of very fine yarn, providing opportunity to make thinner yarn and create more flexible textiles. On the other hand, splicing allowed creating exceptionally fine and glossy yarn, something that is impossible to do with draft spun threads. The next stage is weaving. Weaving is accomplished on a loom, a special frame that keeps the warp system in place while allowing the weft to be passed in between warp threads. In Europe, a warp-weighted loom was used from prehistoric times and well into Roman Empire, when it was gradually supplanted by a vertical two-beam loom, although possibility of other looms cannot be discounted. The warp-weighted loom was made up of two upright beams that stood at a slight angle to the vertical plane and a single horizontal or cloth beam to which warp was attached. In a warp-weighted loom, as suggested by its name, the warp is kept taut by the weights attached to the bottom of the groups of threads. Since weights were made of stone, or usually clay, they survive well in the archaeological context and allow us to trace the presence and sometimes even location of warp-weighted loom on sites. The latest methods developed at the Center for Textile Research at the University of Copenhagen in Denmark also allow to extrapolate the qualities of textiles that could have been woven using loom weights of specific weight and thickness. The basic woven textile is constructed by interlacing two thread systems at right angles. The static system is generally called warp. The perpendicular movable system is called weft. The textile is then defined in terms of its weave. The simplest form of weaving, plain weave or tabby, is produced by weaving threads passing over and under alternate warps. The vast majority of prehistoric textiles are in fact woven in tabby weave. Even in the simplest of weaves, a variety of effects can be achieved by varying the combination of threads, their thickness, and creating, for example, weft-faced weaves which have many more weft threads than warp threads, a basis also for tapestry. In the more complex twill weave, weft threads pass over and under warps in a regular staggered pattern, each row being stepped to the one side of the row above. This creates a diagonal effect. The variants include plain diagonal, warp or weft chevron, broken, and more complex diamond and herringbone twills. Other, even more complex weave include brocade, tapestry, piled structures used in carpets, and numerous others, although these are exceedingly rare in Iron Age textiles of Europe. Due to specific material properties, textiles made of plant fibers were primarily woven in balanced plain weave or tabby, and in fact, majority of textiles found in Spain are tabby weaves. Our investigation of textiles in Italy and Greece so far have in fact demonstrated differences in weave preference of the two regions. As you can see in the different pie charts, there is more variety of weaves in Italy than there is in Greece. And in fact, in Greece, we only have tabby weaves of different types. Despite the fact that technology was the same, they were still using the same type of loom and drop spindle. Obviously, the preferences have to do with aesthetic and cultural determinants rather than the technological or raw material ones. Finally, unlike plant fibers, which generally are more difficult to dye, wool could and was often dyed a multitude of bright colors. Analysis of archaeological textiles used liquid chromatography and other methods allow to identify specific sources of ancient dyes, such as woad for blue, madder for red, variety of the yellow, and the most important of them all, the shellfish purple. These are the examples of the dyes we have been able to determine in some of the organically preserved textiles in Italy. The latter also leaves important archaeological evidence in shape of shells, accumulations of which have been used to identify purple production sites across the Mediterranean, and we will hear about that today as well. The final appearance of a textile is thus a result of complex interactions between resources, technology, and society. In this way, agriculture, animal husbandry, exploitation of environmental resources and landscape use are closely linked to textile production and help us to weave the fabric of the past. So before we begin, we would like to thank all the speakers for participating in this workshop and the National Archaeological Museum of Madrid for enthusiastically agreeing to host the workshop here, and the museum staff for all their wonderful help organizing the event a long distance, and of course the European Research Council for its generous financial support. We also would like to thank all of you for coming here today. The presence of so many of you in this wonderful acknowledgement of the relevance of textile studies in Spain and more widely in Europe. Thank you for your attention.